It's time for trigonometric substitution. We see a difference of squares here within this square root, and that's a key to using trigonometric substitution. If we have a sum or difference of squares and regular substitution doesn't work, we're going to go with trigonometric substitution. The first thing I'm going to do is factor out that 196 so that we can use our basic forms of the integrals that integrate to the arctangent or the arc functions. So we are going to think of this as 196 minus 196x squared divided by 196. We are going to use our powers of multiplication by 1. We're going to do that. That allows us to factor out that 196 through a square root in the denominator. So we are going to be left with this expression. So the 196 that we're factoring out is right there and right there. And it's leaving a 196 under the x squared, which we want to combine as a single square. So we will write it like that. And now we get to decide, should we use sine, secant, or tangent? And we are not using u. We are using sine, secant, or tangent for that x divided by 14. And in this case, we're going to use sine, precisely because 1 minus sine squared, if we replace the x over 14 with sine, we get 1 minus sine squared, and that is an identity. So that's why we choose sine. Secant and tangent will not work. All right, so that's going to give us, let's see, we have in the numerator x squared. Well, that x squared, we need to isolate x over here, so x is 14 sine of theta. So we're going to have 14 sine of theta quantity squared. And now we have to deal with the dx. So dx is right there. And to deal with the dx, we need to take the derivative over here. So the derivative of the left, the derivative of the right will give us that. So if we isolate dx, we see that dx is 14 multiplied by cosine of theta. Or d theta on the side. And then down below, we have square root of 1 minus sine squared. And of course, that's going to be cosine squared. All right, let's do a little simplification here. We see that that 14 cancels with that 14. We are going to have some 14 squareds on the outside. Well, have a 14 squared on the outside, which is 196. And in the numerator, we have sine times cosine. In the denominator, we have the square root of cosine squared, which is cosine. Now, it's not always true that the square root of x squared is x. We know that technically this is absolute value of x. The square root of x squared could be plus x or it could be minus x, depending on what x is. In our trig context, the reason that we would get the square root of cosine squared being cosine is if the angle is on the right side of the unit circle where cosines are positive. If we happen to be on the left side, we would replace the square root of cosine squared with negative cosine x. But we are going to assume, since they haven't told us otherwise, that the square root of cosine squared is cosine. Otherwise, they would have to tell us. Okay, we have a little more cancellation in here. And we also have a missing square right there. I'm sure you already saw that. And we're screaming at the screen. Okay, well, we know that when we have an integral of sine squared or cosine squared, we have to do a power reduction. And so that power reduction is going to turn sine squared into 1/2 times 1 minus cosine of 2 theta. We will pull the 1/2 out to the front. And now we can integrate. And so the integral in the front, let's simplify that. And when we integrate 1, we get theta. When we integrate cosine, we get sine of the same angle. That angle is linear. and it has a derivative of 2, so we have to use reverse chain rule, and then we get our constant of integration. All right, we have a sine of 2 theta. Well, sine of 2 theta can be converted with a double angle identity, and we want to get back to a place where we have just theta as the angle, not 2 theta. So we're going to use that identity. So we will have 98 multiplied by theta minus 2 sine theta cosine theta over 2 plus c. These 2's will cancel. Now we need to convert back to x. To convert back to x, we are going to use our triangle. And the triangle that we build is based on this substitution step up here where we have x over 14 equals sine of theta. So let's draw our triangle. And sine of theta is x over 14. So we want to put we want to label 2 of the sides so that that equation is true. So sine of theta is x divided by 14. All right, that's true. And now we want to fill in the missing side, which is done using the Pythagorean theorem. So that's going to be 196 minus x squared inside the parentheses here. That is going to allow us to do the following. We can now write our answer as 98. Theta, we just isolate theta here by taking the inverse sine of both sides. So we're going to have inverse sine of x divided by 14. And then sine of theta is x divided by 14. Cosine of theta, if we look at that triangle, is adjacent over hypotenuse. So we'll have this plus c. Now we just have to do a little bit of simplification. We'll distribute the 98. So we have 98 inverse sine of x over 14. And then here we're going to get 98 over 196, which is 1/2. And we will end up with, there's an x out in front there. We'll end up with the square root, and that 1/2 we can write as an over 2 plus c. There we have it.